Hey math kids, today we're going to look at section 2C and we're going to talk about how to build functions that model relationships between two quantities. So let's see, let's do one like this. So a local phone company charges 10 cents per minute and there's a fixed fee of $5 just for a monthly plan. Write a function that shows the cost of the monthly plan C as a function of time t. So it says C is the cost and t is time, or like number of minutes that you use the phone. Okay, so I'm going to do my graph right here. So the first thing is, just to own the phone, it's $5. So we have 1, 2, 3, 4, 5, 6, 7, 8. So 5 is right here. So even if you use 0 minutes on the phone, you pay $5. Now every 10 minutes is going to cost $1 because it's 10 cents per minute. So I'm just going to do 10-minute increments. So 10, 20, 30, 40. So for 10, so this would be dollars, and this is minutes used. So if you use it 10 minutes, we bump up to $6. If you use it 20, we bump up to 7, up to 8, up to 9. I know that doesn't look linear, but it should have been. And that's a graph of what it would look like. Now, we want to write a function, though, that expresses this idea. So the reason why I drew it out, though, is because I think it's easier to see our slope. So we rise 1, we run 1. So if we just write this in y equals mx plus b, it's not too bad. So our m is 1 over 1, which is just 1. And then our b, we cross the y-axis at 5. And now all we need to do is replace all the pieces with what we have. So the cost of the monthly plan is what we're using for our y. The time would be x. And then 1 over 1 is just 1, but we don't need to write that. And then we have our plus 5. So it's going to be c equals t plus 5. Okay, moving on. It says Sarah owns a lemonade stand. It costs Sarah $20 to set up her stand and 50 cents to make each cup. Okay, she sells each for $2. If n is the number of cups, and let's see, what is her profit? So P of n equals profit. All right. So once again, we could make a graph, but I'm not going to make it this time. So our y, this is going to act as our y-intercept because it's a set amount. So if I'm doing y equals mx plus b, I'm going to do $20. And then number of cups, that's going to change. And then our slope is going to be dependent on how much money we make per. So since we spend 50 cents and sell for 2, we're actually going to get a slope of 1.5. And then our profit is P of n. So we make a profit of $1.50 on each cup. Oh, whoops. We're losing the 20. So this would be negative 20 because we take that away. So P of n equals 1.5n minus 20 because we make $1.50 per cup, but just to open the stand cost us $20. Okay, we're going to keep moving on. Now we want to write a function that models this situation. Now, these are considered toothpicks. So for example, this is 4 toothpicks. 1, 2, 3, 4. This would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 4, 12, and then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. Okay. So our goal is to model how this is changing. And as we're doing this, we see that this is growing by 8 if we add, and this one is growing by 12. Alright, so that's not constant if we're adding. And then this one, if we multiply, we multiply by 3. So that's multiplication. If we multiply this by this, it's only 2. Now if you're secondary, we see that it doesn't line up, and so it's actually beyond this is going to happen once on your assignment. That's why I'm choosing to do this one. If the addition isn't constant and the multiplication isn't constant, it's actually beyond the scope of this class. And so I just want you to write something like that. So beyond scope of class. So you want to show both of them, but state that it's beyond the scope of this class. Okay. Now we're going to move on to one that we can do. It's going to be similar. So 1, 2, 3, 4, 5. So it's a similar idea. This time we just have dots. So we try multiplication. So to go from 1, 5, 1, 2, 3, 4, 5, 6, 7, 8, 9. If we do multiplication, we'd have to multiply by 5, and then multiply by something that's not 5. So we're not going to do multiplication on that one. Now if we try addition, we add 4, and since those are the same number, we have a linear relationship. So linear, y equals mx plus b. M is the amount that we change by, because it's our slope. And then this is our starting. So we're going to get y equals 4, because that's the amount we change by, x plus 1. Okay. Now, if we plug this in, we have to see how we talk about this, because it's a little bit weird. But if we plug in a 0, so 4 times 0 plus 1, that gives us a 1, and that gives us our starting point. So this function is going to work if we call this our 0 step, and we call this our first step, and this is our second. So 0th step, first step, second step. So it's just important to keep that in mind so that that works out. Okay, let's do another one. So we have 1, we get 2, and we get 4. So we try to add, we add 1, try to add, we add 2. Those aren't the same, so that doesn't work. So we try multiplication. We multiply by 2 to get from 1 to 2. And then we multiply by 2 again, so we're going to use multiplication. Now with multiplication, we have a exponential relationship. And this time A is the starting, and B is the change. So when we write that out, we still have our y. Y equals A, which is our starting, which is 1. And then B is our change, which was multiplying by 2. And then if we simplify that, it's just y equals 2 to the x, because multiplying by 1 doesn't do anything. Now let's test it. So if we plug in a 0, we get 2 to the 0, which equals 1. Then we plug in a 1, 2 to the 1 equals 2, and plug in a 3, or sorry, a 2. 2 to the 2 equals 4. So that means that this really is the 0 step. This is the first step. This is the second step. So as long as we keep that part straight, these formulas will work out. Okay, we have one more type of example. So it's this idea of revenue. So we have revenue, we have cost, and we have profit. Okay. So we have a toy store, and we have a revenue. It's represented by this function. And we have cost. That's 0.42x plus 10. And then it says write a function for the profit. So the profit is just the total revenue, because that's the amount of money coming into a company, minus the total cost. And then that's just what profit is. So what we need to do is fill this out. So we're going to take all of this, negative 0.05x squared plus 50x plus 20. Then we are going to subtract all of this, 0.42 plus 10. So we do some polynomial stuff, combining like terms and distributing negative. So this is negative 0.42 minus 10. So this combined with this is just going to be a 10. Wait, there should be an x right here. So 50 minus 0.42 is going to be 49.58 x. And then nothing combined with this. So we have that. And so our profit function is that. Okay, that's all they asked us to do on that one. So if you need additional help, come to Math Lab. Until then, calculator.